Do you know why is it important to study reaction kinetics? Yes, so that we are able to control the rate of the reaction. For example, if you are a chemist producing new drugs, of course you want to produce it quickly and safely. But not all reactions need to be accelerated. There are some reactions that people try to slow down. For example, aging process and rusting. Now, let's discuss about differential rate equation. Let's say we have a chemical reaction here where nitrogen gas reacting with hydrogen gas to produce ammonia. If nitrogen gas is disappearing at the rate of 0.1 mole per dm cube per minute, from the stoichiometric coefficients of the balance equation, we can see that concentration of hydrogen is decreasing 3 times as fast. That is 0.3 mole per dm cube per minute, while concentration of ammonia is increasing 2 times as fast. That is 0.2 mole per dm cube per minute. Now, let's discuss how to write the differential rate equation. As time goes on, we know that concentration of the reactant will decrease, while concentration of the product will increase. So, to write the differential rate equation, we have to start writing the rate first and equals to minus d concentration of the reactant N2 over dt. The reason why we write minus is because concentration of the reactant decreases. And it is also equals to minus 1 over 3 d H2 over dt. Okay. The reason why we write minus is because hydrogen gas is the reactant. And 1 over 3 is because the stoichiometric coefficient is 3 and is also equals to positive 1 over 2 d NH3 over dt. Alright, we write positive because ammonia is the product. So this is differential rate equation. When we write the differential rate equation, we must know that the unit of the concentration is always mole per dm cube, or mole per liter, or in molar. But the unit of the time is always unit of the time can be in any unit. For example, seconds, minutes, hours, days, months, years, decades, and so on. Now let's try this example. For this reaction, write the differential rate equation. So remember, we need to write rate first. Rate is equals to minus 1 over 2 d N2 or 5 over dt and is equals to positive 1 over 4 d NO2 over dt and is equals to positive rate of oxygen gas. Okay, and then during the reaction, N2O5 is reacting at the rate of 0.024 molar per second. The question, calculate the rate of formation of NO2. So, to do question B Roman 1, okay, the question gives us information about N2O5, but the question is asking about NO2. So we have to write the relationship between the two species. The relationship is minus 1 over 2 d N2O5 over dt is equals to positive 1 over 4 d NO2 over dt, the rate of NO2. Then, since now given is 0.024, meaning that 0.024 is the value of d N2O5 over dt. So, we can write 1 over 2 times 0.024, and this 4 here we can bring it up, so it becomes times 4 and is equals to 4 divided with 2 is 2 times 0.024, so we can get 0.048 molar per second. Alright, when you write the answer, you can just ignore the sign, positive or negative sign. But then, okay, the final answer you have to write in sentence, rate of formation. Okay, rate of formation of NO2 is 0.048 molar per second. So this is the final answer. Then the next question is calculate the rate of the reaction. Okay, to calculate the rate of the reaction, okay, where can we calculate the rate of the reaction? We can see from the differential rate equation. We have the word rate there. Okay, now concentrate. The rate of N2O5 is given. And then also the rate of NO2 we already found out that is 0.048 molar per second. So to calculate the rate, it's either we relate with N2O5 or we can relate with NO2, because these two we know the value. Okay, so let's say I relate with N2O5, so I can write rate is equals to -1/2 d N2O5 over dt. So rate is equals to half of 0.024. So the rate of the reaction is 0.012 molar per second.